All right. In section 6.3, we had addition and subtraction formulas for being able to find, or which enabled us to find exact trigonometric values for angles we did not have memorized on the unit circle, as long as we could figure out a way to write the angle that we wanted in terms of the addition or the sum or difference of two other angles. I think we found maybe the some trigonometric function for, say, 165 degrees by writing 165 degrees as 135 degrees plus 30 degrees. That allowed us to find any trigonometric function, the exact value that we would not have been able to find without the addition and subtraction formulas. So in 6.4, we have double angle and half angle formulas. And on the test, when a problem says find an exact value, there may be several ways to do the problem. You may be able to write the angle we're talking about as a sum or difference of angles that we do have memorized on the unit circle, or you may recognize it as, hey, that's half of something that I have memorized, or double something that I have memorized. So all of these formulas, all of these at the top, are to help you be able to find exact values that you couldn't find otherwise. Now, the only one of these double angle formulas that I use often enough to actually have it memorized is the sine of 2u is 2 sine u cosine u. So, for example, if I was looking for the sine of, let me think, I'll just get to an example in a second. But if I recognize that the angle I'm looking for is double an angle that I have memorized, then I can use one of these double angle formulas. There are 3 different double angle formulas for cosine of 2u. It shouldn't matter which one of the 3 that you use, you should get the same answer. The only time it matters is when you're verifying identities. Sometimes one of these 3 will get you there faster than the other 2. And then we have half angle formulas that we'll talk about in a minute. So the very first problem, say find the exact values of sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Let me see if I can get focused just a little bit better on that. Not really. Okay, so let's try number 4, page 452. All that we know is that sine of theta is negative 12/13, and we're given that theta is between 270 degrees and 360 degrees. Now, do we have memorized on the unit circle an angle whose sine is negative 12/13?
No.
No, we don't. So I don't know what that angle is, but I can draw a picture of it. And in what quadrant does that angle lie? Oh, that's supposed to be theta, not 0. In what quadrant does theta lie if it's between 270 degrees and 360 degrees?
4.
That's quadrant 4. So I'm going to draw a 4th quadrant angle. Raise a vertical line up to the x-axis and say that is theta, and I need to label that angle in such a way that sine of theta is negative 12/13. That means opposite must be negative 12, hypotenuse must be 13, and by the Pythagorean theorem, I always feel like I'm saying by the powers invested in me when I start that sentence. By the Pythagorean theorem, the adjacent side is 5. Now that I have that triangle, I can find the sine of 2 theta and I can find the cosine of 2 theta, and I can find the tangent of 2 theta. Again, that's without ever knowing what theta actually is. I could get a decimal approximation of theta with my inverse sine button on the calculator, but we're trying to stick with exact values, and I don't have to know the exact value of theta to find these trigonometric functions of 2 theta. Sine of 2 theta is 2 sine theta cosine theta, and I can extract the values of sine theta and cosine theta straight off of that triangle. Oops. Sine theta is, well, even without the picture, we knew what sine theta was, -12/13. And from my triangle, I can see that cosine of theta would be 5/13. Now, I forgot to say something, and it wouldn't matter on this problem, we'd get it right anyway, but make sure that you're checking if theta is in the 4th quadrant, you know opposite, or you know the y coordinate's going to be negative, but make sure you check the sign of the x coordinate. In the 4th quadrant, the x coordinate is going to be positive, so that +5 is correct. And sine of 2 theta would be -120/169. For cosine 2 theta, any, miny, miny, mo, you could use any of these 3 formulas. Since we were given sine of theta, I think I'd use this formula. But it doesn't matter, you should get the same answer either way. Cosine of 2 theta is 1 minus 2 sine squared theta. And we know that sine is -12/13, and that's supposed to be squared. 2 sine squared theta. That would be 1 minus 2 times 144/169. And I'm just going to say you can punch that on the calculator. But that would annoy me if I did, so I'm going to get a common denominator. And say that that's 9. Is that 119? 288, yeah, 119/169. All right, how about tangent 2 theta? I have a formula for tangent 2 theta, and I could use it. But, Evan, can you think of an easier way to find tangent 2 theta than to use that formula?
Not this early, no.
We know sine 2 theta, we know cosine 2 theta. How could we find tangent 2 theta?
Oh, just do sine over cosine.
Mr. Evan, are you still with me?
Can you not hear me?
Can now. That's the last I heard. Can you not hear me? That was the last thing I heard. So tell me just a little bit louder how we can find tangent 2 theta.
Could you do just sine over cosine? Or
Without having to use the double angle formula for tangent, we can just say tangent 2 theta is sine 2 theta divided by cosine 2 theta, which it would be 120/169 times the reciprocal of cosine 2 theta, which would be 169 over 119. So tangent to theta would be negative 120 over 119. So that's how you use the double angle formulas. For all of 1 through 4, you would just, without having to know what theta actually is, you could draw a picture of theta and put it in the right quadrant, pay attention to your signs, and then use the double angle formula for sine 2 theta, cosine 2 theta. Find tangent 2 theta by dividing sine of 2 theta by cosine of 2 theta. Number 6, let's go ahead and do it for one more example. Number 6 says, find the exact value of cosine 2 theta, and all we're given is that cotangent theta is 2 and theta is acute. In number 4, we had to know that theta was in the 4th quadrant to know that our x was positive and our y was negative. This is giving us the same information. If theta is acute, in what quadrant does, that's not theta, alpha. If alpha is acute, in what quadrant does alpha lie?
One.
Yeah. So both the x and the y are positive. If cotangent is a half, oop, I said the answer. If cotangent is 2, what's tangent? A half. So the opposite is 1 and the adjacent is 2. And you can draw a picture of that first quadrant angle. Label it alpha. Drop a vertical line down to the x-axis and say the side opposite alpha is 1, the side adjacent to alpha is 2. If we need it, what does that mean the hypotenuse is?
That's 2 squared.
Square root of 5. Square root of 2 squared plus 1 squared. All right, and all we were asked to find in number 6 is cosine of 2 alpha. And again, we could use any, many, miny, mo, either one of those 3 formulas. I like using the second or third because I only have to find the value of one of the trig functions, but it absolutely doesn't matter. If I want to use 1 minus 2 sine squared alpha, then all I have to find from this triangle is what is sine alpha. What would sine alpha be?
That's 1 over square root of 5.
Right. Opposite over hypotenuse would be 1 over square root of 5. And that's supposed to be squared. 1 over square root of 5 squared is just 1/5. 2 times 1/5 is just 2/5. And 5/5 minus 2/5 is 3/5. So the double angle formulas are very straightforward to use. I need to tell you something about the half angle formulas though. The half angle formulas for sine and cosine both have a plus or minus. And we have to figure out, based on where our angle u is, actually where our angle u over 2 is, we have to determine in what quadrant u over 2 lies so that we know whether to use the plus or the minus each time we use a half angle formula for sine or cosine. Let me show you what I mean. For example, let's see. let's do number 8, which says if cosecant theta is -5/3 and theta is between -90 degrees and 0 degrees. Find sine of theta over 2, cosine of theta over 2, and tangent theta over 2. Just remember, whenever you're using the half angle formulas, you have to determine in what quadrant theta over 2 lies. Well, in what quadrant does theta lie? If theta is between -90 degrees and 0 degrees, what quadrant is that? -90 degrees to 0 degrees would be the 4th quadrant, because we're
Can you hear
counting.
me?
I didn't then, but I do now. You're just kind of coming in and out, so I'll ask.
Yeah, I can tell.
That's okay. I'll ask a question, and if I don't get an answer in just a couple of seconds, I'll go ahead and answer it myself. In the videos anyway, I like to leave time for folks to be able to think about the question I ask instead of zooming right into an answer. So theta is in the 4th quadrant. If theta is between -90 degrees and 0 degrees, what's theta over 2 between? It's okay to divide all 3 sides of a compound inequality by 2, and you get theta over 2 is between -45 degrees and 0 degrees. So in what quadrant is theta over 2? Well, that happens to still be the 4th quadrant. So theta was in quadrant 4, theta over 2 is still in quadrant 4. And I know in quadrant 4, all of my x's are positive, but my y's are negative. And I'll tell you why that's important in just a second. All right, let's draw a picture of this 4th quadrant angle and label it in such a way that cosecant is -5/3, or if your brain doesn't like dealing with cosecant, you can say if cosecant's -5/3, then sine is -3/5, and that means opposite is -3 and hypotenuse is 5. So a 4th quadrant angle whose opposite is -3, hypotenuse 5. In the 4th quadrant, would this adjacent side, this x coordinate, be positive or negative? It would be positive. Yeah, I heard you. Okay, so that's +4. That's our 4th quadrant angle. And we're asked to find sine of half theta and cosine of half theta and tangent of half theta. And I'm going to have all these formulas on the test. So for sine of a half theta, here's where I hit the plus or minus, and I have to know whether to use the positive or the negative square root for sine of a half theta. Well, sine is your y coordinate, and we said theta over 2 is in the 4th quadrant. So in the 4th quadrant, would I use the positive or negative from this formula?
Negative. Negative.
In the 4th quadrant, sine would be negative. So I'm going to use the negative square root of 1 minus cosine theta over 2. And I can extract cosine theta straight from this triangle. Cosine theta would be 4/5. All right, over 2. So 1 minus 4/5 is 1/5. 1/5 over 2 is 1/10. Square root of 1/10 is 1 over square root of 10. I'm so fine if you leave that. If you rationalize it though, you have negative square root of 10 over 10. So using the formula is easy. Just pay attention to the quadrant in which theta over 2 lies so that you know whether to use the positive or the negative for the formula. For cosine theta over 2, it also has a plus or minus. So I have to say if theta over 2 is in the 4th quadrant, for the cosine, would I use the positive or the negative from this formula?
Positive.
Yeah, cosine's your x, and in the 4th quadrant, x is positive. So I'm going to use the positive square root of 1 plus cosine theta over 2. And cosine theta, we've already said, is 4/5. And 5/5 plus 4/5 is 9/5. 9/5 divided by 2 is 9/10. Square root of 9/10 would be 3 over square root of 10, or rationalize it and you'd have 3 square root of 10 over 10. And then for tangent theta over 2, you could use one of these two formulas. Either one should give you the same answer. But if you've already calculated sine of u over 2 and cosine of u over 2, you don't really have to use either of these formulas to find tangent of u over 2. You can just say tangent of, in this case, theta over 2 is the sine divided by the cosine. It's actually easier on this problem to use the values before we rationalize the denominator. I'm just going to say sine of theta over 2 divided by cosine of theta over 2 would be negative 1 over square root of 10 times the reciprocal of 3 over square root of 10. And that would just be negative 1/3. Now on this problem, we probably would have gotten the correct sign, S-I-G-N, on both sine and cosine, even if we had forgotten to pay attention to in what quadrant theta over 2 lies. But sometimes if we don't pay attention to that, we're going to get these S-I-G-Ns wrong. Let me show you an example of that. Let's see. Let's do number 12, which says secant of theta is negative 4, and theta is between 180 degrees and 270 degrees. All right. So in what quadrant does theta lie? from 180 degrees to 270 degrees is quadrant 3. And I know in quadrant 3, both my x's and my y's are negative. So when I draw this third quadrant angle, I'm going to make sure to label both my x and my y negative. But theta over 2 is not in quadrant 3. If theta is between 180 degrees and 270 degrees, what's theta over 2 between?
90 degrees.
90 degrees and 135 degrees, which isn't quadrant 3 now. It's quadrant 2. And in quadrant 2, my x's are negative, but my y's are positive. So when I use the half angle formulas, I'm going to use the negative for cosine and the positive for sine. If secant theta is -4, cosine theta is -1/4, and that gives me the adjacent side and the hypotenuse. So remember, we're not graphing theta over 2, we're graphing theta. And theta is in the third quadrant. Where the opposite side is -1. No, I'm sorry, adjacent's -1. Hypotenuse is 4. And by the Pythagorean theorem, the adjacent side, excuse me, the opposite side would be square root of 16 minus 1 or square root of 15. Now, if I stop right there, what's wrong with my picture? Since theta is in the third quadrant, I know that both the adjacent side and the opposite side, the x and the y, are both supposed to be negative. So if you're not paying attention, you'll miss that. All right, now let's find, we're asked to find all the same things. Sine, we'll just find sine of theta over 2 and cosine of theta over 2, because I know if you had those, you could find tangent theta over 2. For sine of theta over 2, or sine of u over 2, am I going to use the positive or negative square root? We determined that theta over 2 is in the second quadrant, and in the second quadrant, our y's are positive. So we're going to use the positive square root of 1 minus cosine theta all over 2. And then for cosine, we have to say theta over 2 is in the second quadrant, and in the second quadrant, our x's are negative. So for cosine theta over 2, we would use the negative square root. I just realized that we didn't even really have to draw a picture on this one, because both of these formulas only use cosine, and we knew what cosine of theta is. We were given cosine of theta as -1/4. So we really didn't need the opposite side and the hypotenuse. Oops, I lost my negative. Right there. No, that's not 10. 4/4 plus 1/4 is 5/4. 5/4 divided by 2 is 5/8, not 5/10. You could rationalize those, and I'm pretty sure that on the test, since the test is going to be in MyMathLab will probably want you to rationalize the denominator, so you should. But what I'll do, I had to do this on the calculus test last time, I'll go back through your test after MyMathLab grades it and see if you missed any problems just because you forgot to rationalize the denominator. I'll give you credit for that. Or if your answer is equivalent to the answer MyMathLab was expecting, then I'll go in and give you credit for that. That raised quite a few people's grade on the last calculus test. So I'll do that for you too. All right, there's only one other thing I need to show you, and it's number 16. Number 16 has parts A, B, and C, and part A is find cosine of 165 degrees. Find the exact value of cosine of 165 degrees. We could find a decimal approximation on the calculator with no problem at all. But to find the exact value, we have to recognize 165 degrees as either double something that we know or half of something that we know. Can you tell me whether 165 is half of an angle that we have memorized or whether it's double some angle that we have memorized?
Half.
It's half of what?
330.
Yeah, it's half of 330. So if this is our u over 2, and that's cosine of u over 2, then u, our original angle, would have to be 330 degrees. And so we can look at cosine of 165 and say that's the same thing as cosine of 330 degrees divided by 2. Now, 330 is one of our quarter pies. Wait, 270 and 45. No, it's not. It's 270 and 30. It's right here. 330 is right there. Oh, darn it. It's right there, close to the x-axis, which means the ordered pair is square root of 3 over 2 negative 1/2. U lies in the fourth quadrant, but where does a half of that lie? Where is 165 degrees? Would be in what quadrant?
Second quadrant.
All right. Second quadrant, where my x's are negative, but my y's are positive. So cosine of 165 degrees would be, let me show you the formula. Eeny, meeny, miny, mo, let's use this one. 1 minus, oh, I almost used a double angle formula. I meant to use a half angle formula. Should I use the positive or negative square root for cosine of 165?
Negative.
It's in the second quadrant, and in the second quadrant, cosine's negative, so I'm going to use negative square root of 1 plus cosine of u, which is 330 degrees, over 2. And cosine of 330 degrees is square root of 3 over 2. That just means this answer is going to be pretty ugly, a radical under a radical. If you wrote that 1 as 2 over 2 and got a common denominator, you'd have 2 plus square root of 3 over 2 in the numerator, and then when you divided that by 2, you'd have 4 in the denominator. Another way, it may be easier for you to think about it this way, if you multiply under the radical by 2 over 2 to clear out the baby denominators, this is what you would get. And that's okay, but you probably wouldn't leave it that way, because you can take the square root of 4 and just bring that coefficient 1/2 out in front of the big radical. Now that was some funky math. Evan, does it make sense? Did you follow that?
Yeah.
Okay. And Carly, I assume if you didn't follow that, you'll send me a message in chat real quickly. Otherwise, we're going to assume that's okay. All right, last one. Let's do the C part. Tangent of pi over 8. Ooh, let me see what Carly said. Carly got it. Good, good, good. All right, so again, pi over 8. Is that half of something we have memorized or double something we have memorized?
Half.
It's half of what?
Over 4.
Yeah, tangent of pi over 8 is half of pi over 4. So we're going to use one of the two half angle formulas for tangent, with our u being pi over 4. The half angle formula for tangent, we have 2 of them. Eeny, meeny, miny, mo, I'm just going to use 1 minus cosine pi over 4 divided by sine of pi over 4. And you can tell me both of those values. They're both in the first quadrant. Cosine of pi over 4 is square root of 2 over 2. And sine of pi over 4 is square root of 2 over 2. And if you just multiplied that whole fraction by 2 over 2 to clear out the complex fractions, that would be 2 minus square root of 2 over square root of 2. And if you're supposed to rationalize that denominator, you would have 2 square root of 2 minus, that would be square root of 4, which is just 2, over square root of 4, which is just 2. And that is probably not the answer in the back of the book, because there's one other thing you can do to simplify it. Evan, what would that be when I simplified it one more step?
Divide everything by 2.
Divide both of those terms by 2, and you would just get square root of 2 minus 1. Now, if we had used this formula for the half angle formula for tangent, we may have gotten that more directly. It doesn't matter. If I use this formula, even if it didn't come out to be this, it would be something equivalent to that. All right, that gets us through 1 through 15, which is the first half of 6.4. The second half of 6.4 are these verify the identity problems, and they're as easy as the verification problems we had in 6.3. You just use a double angle formula or a half angle formula to show that the left-hand side is equivalent to the right-hand side.